this is already taken care by the algorithm, so you really don't have to bother, right? So you don't have to bother, so it is commented here. You don't have to do data validation or data categorization because there is no text fields. It's just a simple two fields. Now first see what I will do. I will assume that it is a linear regression. So I will take this and I will fit the linear regression. Means I use the linear regression class and then I will basically train the model with the data set X and Y. Okay. Now what I will do, I will fit the polynomial regression to the data set. Okay, now having done this, what I will do is, let me do one thing. I will visualize. Just omit this for now. Okay, just omit this for now. I will just visualize the linear regression results. So whatever model has been trained and it has come out with a pattern, I will try to visualize how it comes. Okay. You see how the data is? The predicted line is a straight line, but my actual data is somewhere different. See, there's a lot of data which is away from the predicted line. That means my linear regression model will not work here. It's not going to work. Okay. Now assuming that if if you see my data, suppose somebody has joined as a regional manager. Some new guy has joined as a regional manager, okay, of the organization, and he's a little more experienced than a regional manager, right? So what is the sort of salary you'd like to give, right? So typically what I would give, I'll give a salary between either 150k or somewhere between 150k and 200k, because 200k is the next level. Okay. Now if I were to do this prediction here, say I come down, I do a prediction here. See, there is something here. This is showing that please predict from the linear regression model, please predict that if my x value is 6.5, what should be the predicted output value. Okay. Now if I run this, you see the value, it comes to 330,000. 330,000 if you see here, it is coming where? Even more than the senior partner level. It is coming to nearly the little less than the C level guy, right? So that means this model is not correct, because this model is giving me a very wrong answer, incorrect answer. Okay, so that means my linear regression model is not working here. Okay, have you guys understood till now what I have said? Yes or no? Please answer yes or no. Till now, whatever I have said, have you all understood? Okay, Preeti has understood okay, because we have already done this linear regression, right? So what I'm doing here, I have the data, I'm running a linear regression model, and I see that for a particular independent variable, I do a prediction and see whether it fits as per the actual data set, and I see it is quite wavered. I mean, it's quite out of range. Okay, that means my linear regression model is not working here. Okay, so what I will do is, now I will do another thing. Now I will use a poly regression model. So I will use something called polynomial features. Now what here I have to do, there is something called degree. When I say degree equal to 4, you say x1 x square plus x plus x square plus x cube plus x raised to 4. When I say degree equal to 4. When I say degree equal to 3, it is x cube. When it's degree equal to 2, it is x square. Okay. So what I will do is, I will have to try out this degree. I will first try with x square and see whether the model fits. Then I will try with x cube, and then I will see whether the model fits. Then I will try degree equal to x4, that is 4, and see whether the model fits. Okay. So what I will do for the time being, I will take degree equal to x square. Okay. Assume that I get only 2. So I will run this. This is running the model, and now I will visualize using the polynomial regression result. See what happens. You will see that it is better than earlier, right? Earlier it was a straight line and you had lot of dots around the straight line. Now you see it is predicting some sort of parabolic curve, but my dots are still farther away from the predicted line. That means this model is still not correct. Okay, and if I were to do the prediction now, see, if I do the prediction, from polynomial regression. Now with 6.5, what will this show? It is showing 189,000 as against 330,000 which was shown by the linear regression model. For 6.5, here it is showing 189,000, but 189,000 is okay, but maybe I could get more accurate results. So what can I do? Let me try x equal to 3. So I go back, I make here x degree equal to 3, okay, and let me again run this, okay. Now let me do the visualization for the polynomial. See, this is still more accurate, right? What you saw with degree equal to 2, where there were still some points which were outside the predicted line, here if you see it is still better. Now if I go down and do a prediction, it is 133,000. Okay, it is showing 133,000. Now if you see my DES data, my 133,000 is between a country manager and regional manager. Okay, but typically I would have expected something more than 150,000 because he is joined as a regional manager. He's a little more in terms of experience like a regional manager, but I cannot give him a salary. If I have to, the model has to give him some salary which is between 150k and 200k, 200,000, right? So 130,000 is still, I feel, is little less. So what I will do is I will select degree equal to 4. So where is degree equal to 4? I will select degree equal to 4 now, and if I see this, I run this, and then what I do the visualization. See, this is a perfect fitting, right? See, with degree equal to 4, when I do the plot, you see the predicted line and the actual dots are more on the same line, right? It is really matching. And if I now to predict this, it is around 158,000. That means it is pretty correct. It is something between 150k and 200k. So this is how I will vary the degree of the independent variable and find out which is at which level, at which degree you will get more of an accurate answer, where the prediction is close to the actual data, right, or the actual data. So this is typically this is how a polynomial regression works. Okay, any questions at this point of time? Have you understood what is polynomial regression? Anybody, yes or no? If you don't understand, I will repeat it again, but I would like to have your answers on chat. Okay. Okay, so Bhageshri is saying repeat. Okay. So Bhageshri, please tell me at what stage you did not understand. Because I presume to the level 1 till the linear regression you have understood, right? Because all of you have said yes. Okay. So I'm assuming that you have understood what is linear regression. So what I told you earlier, that when I run this particular script with a linear regression class, and when I did the fitment of the data set after the model was trained, I got a prediction which was wavered, right? It was very out of range. That's why I decided, let me try a polynomial regression. So what I did is I took this. So instead of doing the linear regression, I used this code to basically train. Okay. Basically to feed this model using polynomial features, which is a class which I use, and basically now using polynomial features, I want to vary the degree of x. Whether it is x square, I should take x cube, or I should take x raised to 4 or x raised to 5, right? So what degree should I take, right? So to decide the degree, there is one parameter called degree equal to 4. Degree equal to 4 means x raised to 4. So I have to vary these to see at which power of x I get an accurate result. So what I did, I started with degree equal to 2, right? I ran this particular thing, okay, and I did the plotting of the polynomial regression. See, it was wavered here, right? The since the still dots are not coming in the line, right? Okay, and then if I did a prediction, the prediction also was wavered because it was giving some, I think, 200,000 or something, 189,000, right? Because typically for regional director level, if I want to join at 6.5, I should get something between 150,000 and 200,000. Okay, 189,000 is still okay, but I could have let me try out with some with manipulating the degree and see if I could get better results, right? That's why what I did, I again varied the degree equal to 3, then I varied degree equal to 4, and then found out the optimum value of the degree, which will give you a very accurate answer for 6.5, which will give you an most accurate salary. Okay, so this is how we work, we do the polynomial regression. Have you understood, Bhagyashree? I think whoever did not understand, have you now understood? Who was the person who did not understand? I think Bhagyashree, she left just now, I saw her. We have understood, Bhagyashree? Okay, great. Okay. So now you guys understood the concept. So we talked about simple univariate regression, we talked about polynomial regression, and also now we talked about the simple multivariate and now polynomial regression. Okay, so with this we have covered the regression as a section. So the next thing that we are going to move to classification. So can again someone tell me what do you mean by a classification data? What do you mean by classification data? Can you please send on the chat? What is the difference between regression and classification? Quickly on chat. What was the difference between regression and classification? Yeah, I need some answers on chat, please. What is the difference between regression and classification? I don't see any pop-up coming. So you're saying, Fatima, what discrete data for what? I mean, what is discrete? Which value is discrete in classification? Is it an independent variable or dependent variable or what? Shruti, I have not heard you, Shruti. Correct. Dependent variable is discrete, right? That means it has got a fixed set of values in the case of classification. Okay, as against in regression where the dependent variable is continuous, right? Now let me go to one slide. Now this is a very popular data set called the vertebrate data set. It's a very, very popular data set. So generally whenever we start our exercise, as you do a hello world, right? When you start learning a C language or any language, we start any of our machine learning training or using this vertebrate data set. It's one of the really popular data sets. Now can somebody tell me from this data which is the dependent variable? Out of these, which is the dependent variable? Anybody? Which is the dependent variable? So you got name, you have the body temperature, you have the skin color, you have gives birth, aquatic creature, correct. So your class label is your dependent variable, and that class label depends on the combination of the other features, the name, body temperature, skin color, and so on, right? So this is a classic example of a classification data set, right? And name is independent variable. So all the others are independent variable. Name, body temperature, skin color, gives birth, everything else are independent variables. Only the class label is a dependent variable. Okay. Now in classification, there are three things we will cover: logistic regression, we will cover decision tree classification, and we will cover random forest. Okay. Now logistics one, again the concept as we saw in regression. What we did in regression, we did the data pre-processing, we split into training and test set. Okay, then what we did, we basically did the training of the training data set into the model got trained. Okay, it derived a pattern, then I fed the independent variable from the test data and predicted the salary for the dependent variable in regression, and then did the comparison, and I did a model efficiency. So what was the parameter to measure the model efficiency for regression? What was the parameter we used, or what is the, remember what was the parameter we used? I am not talking about comparing the y-pred or y-test visually or using matplotlib. What was the third option? We use some parameter to measure the efficiency of a regression model. What was that? Correct. Shruti said R2. Never say R square. Huh? It is R2 score. Okay. So R2 is based. And what was the formula for R2? Anybody remembers? What was the formula for R2? Can somebody tell me what is the formula for R2? You can write it down. Yes, Shruti, others, Fatima, come on. Put down. What is it? Forgot. What happened? Okay, let me go back to the slide. Do you remember this slide? 1 minus sum of square residual divided sum of the square total, where sum of the square residual is sum of yi minus y credit to the whole square. So what is this called? You remember what was this called? Yeah, so what is this called? SS residual. What is this called? And remember I talked to you about a term which we have to minimize in regression model. What was this? Was it called? Can anybody tell me what is it called? We forgot cost function. Remember cost function? We use the word called cost function. So the idea of regression model is to minimize the cost function. That is, sum of yi minus y credit the whole square should be minimum, right? So if sum of y square minus y prime is minimum, so SS residual should be close to 0. That means my model is most efficient when my R2 score is close to 1, right? And we found in that case the efficiency was 97%, if you remember when we ran the model yesterday, right? Okay, so coming to classification, again here as I said, the principle is the same, but here only difference is that the prediction you anyway have to do. So when you do train the model, then next you take the test data, you take the independent variable of the test data, feed it into the model and derive the output, okay? And you derive the predicted output, and that predicted output should have the same values as the actual data. If you are having 0 and 1, then your predicted value should also have 0 and 1. If your predicted value has got yes or no, it should also have the same value yes or no. Or it is having 0 to 8, it will have the same values, right? So the predicted value again will have a range of values which will be as per the range of the output variable, right? Which is the actual data. And as against R2 score, we have a different way to measure the accuracy of classification model. I will come to that. But first, let's go through this logistic regression. So what I will do, I will go back. I will change my folder. So what I will do now, if you remember, I had another folder called classification. So I go to classification, I go to logistic regression, and I select folder. And if I go to files, there's something. If I go to the data set, okay. Now this data set has got a user ID, a gender, a age, estimated salary, and purchased. 0 means you purchased a car, 1 means you don't purchase a car, and 1 is purchasing a car, right? So this is another example of a classification data where your purchase yes or no, or 0 or 1 is basically, so this is essentially an automotive company which has done a survey on the website, and everybody has got a user ID to log in, right? So you got user ID which is unique, and they enter their profile, their gender, the age, the estimated salary, and then they basically tick on something whether they want to buy a particular brand of car or they are not going to brand of car, right? Now after having collected this data, the customer wants to come out with some model which will do a proper prediction of this data, right? So he is coming to data scientists like us and tells us, I have this data, can you come out with a data model, machine learning model, right? So what I will do is, now I will open my logistic regression.py. Okay. Now again, if you see here, the data pre-processing steps are absolutely the same. So I will first import NumPy, I will import Matplot, I will import pandas, I will take the data set. Now in this data set, please remember, in the data set, right, there are 400 records, right? Now in this data set, what the customer has told me that please focus on age and estimated salary. I don't care about the gender. I don't care about the user ID, because user ID is anyway, a person is logging into the portal will have a unique ID. So that doesn't matter to me when I do a machine learning analysis. So client is saying you don't care about the sex, you just focus on the age and the salary and basically come out with a prediction of the whether a guy is going to buy a particular brand of vehicle or not, right? So what we will do in this case is, so if you see here, when I've taken X, I have only taken 2 and 3, that means the third column and the fourth column, right? That is my age and salary. If I see here, 0, 1, 2, this is my third column and this is my fourth column, right? 0, 1, 2, colon 2 and comma 3, right? So I have taken age and salary, third column and fourth column, right? So I take this. So if I take X, this is my age and salary, right? And if I take Y, which is my fifth column, this is my whether the guy is purchasing a car or not purchasing a car. Okay. So what I will do now, okay, now assuming, do I have any missing data? Do you have any missing data here? Do you see any missing data? Yes or no? Okay, I don't see any missing data. So I don't see any value like NaN, right? So I'm good. So I don't care about missing data, so I'm fine with that. Do I have to do data categorization? Do I have to do data categorization? Anybody? No, right? Because I don't have any text. If I would have used a male or female, if I use a gender here, then probably I would have done a data categorization as 0 and 1. Okay? 0 for male and 1 for female. Okay? Otherwise, since I have not taken this in the purview of my machine learning analysis, I don't have to do any data categorization, right? Then, of course, next thing I have to do a split. So I do a split. So I got 75% training data, 25% test data. Okay. So now if I see my X test, okay, X train is 302 because there are 300 records and two columns. That is my age and salary. and X test is 100 records and 2 columns. Okay. Similarly, Y is 400, 100. Y test is 100. Y train is 300. Correct. So this is how I have split my training set and test set. Now, here what I have to do is, in this case, do I have to do any feature scaling? Do I have to do feature scaling? Guys, do I have to do feature scaling? Is it required or not? No. Very good answer. Very good answer. Anybody else who follow who agrees with Shehzadi? Anybody else who agrees with her? Shruti, what is your answer? Do you need to do feature scaling? Come on, tell me, yaar. You guys should know by now. Shruti is saying yes. Okay, anybody else? Anybody who is supporting Shruti? Neha is also saying yes. Anybody else? Do you require feature scaling? Anjana says no. Very good. So Anjana is listening to the instructor. So guys, we need to have, right? You have age and salary. Why you need to have feature scaling, right? It's very, I mean, we explained so many times, when we have numbers which have got different ranges, you need to always better to do feature scaling. Okay. So here in this case, in the case of logistic regression, in the case of, if you remember, in the case of linear regression, feature scaling was part of the algorithm. You didn't have to do explicit feature scaling. You had commented the code. But here in the case of logistic regression, you have to explicitly do feature scaling, and that's where we use your standard scaler. You know, as we said yesterday, standard scaler has found out to be more. We try both the options, but you can try both standard or min max scaler, and depending on the performance, you take a call. So here, if I do standard scaler, okay, and if I do xtrain here, xtrain, you see the values have come down between -1 and 1, okay, something very small, right? Xtest, okay, so now you have feature scaled, you have brought it to a common base scale. So you have completed the pre-processing, right? Next step, very same thing you do, you feed the training data, xtrain, ytrain, into my logistic regression model. Same thing I did. Then here I am doing the same thing. I do a prediction of ypred where I am taking xtest as my input. Same thing. What I did for regression, principle is same. Nothing is changed. So I do this. Okay. Now what I do, I will try the 3 methods. First method, I will go to ypred. I'll open ypred. I bring it here. I open ytest. I bring it here. Right. Now I compare ypred and ytest. Okay. Now if I see here, there are around 100 records. Okay, we'll not go through all the 100 records, but just an example. Where my y actual data is 0, that means he's not buying the car. Ypred also says that he's not going to buy the car. Ytest, so these are all 0. So it is nearly matching. So the model is really predicting the actual data. This model is predicting the actual data. You go down 7th record, 10th record is more or less fine, right? But if you see, notice in 9th column, 9th row, my actual value says that he's not going to buy the car. But my prediction value says that he's going to buy the car. There's something wrong here, right? So this is one of the anomaly you have. Okay, one of the errors you have. Let's go down. Again, in row number 18, we are good. Row number 21 also is good. It is predicted correctly. Row number 22, 23. Okay, it is okay 25. Okay, this way basically you can compare. Okay, now the second way that I can compare is I do what? I do the visualization. Now see how it looks. Okay, this is what you see. If you see in the case of regression, you had a straight line and then you saw the dots around, right? Now what in logistic regression you have is a prediction boundary. This line is basically, this is a prediction bound. It's a linear line, but it's a prediction boundary where to the left of the prediction boundary is basically the model is saying that these are the guys, the model has predicted that they are not going to buy the car. And to the right of the prediction boundary, these are the points where the person's it is going to buy the car. The prediction is that he's going to buy the car. So on the left of this linear prediction boundary is the prediction from the model that these are the samples who are going to buy the car or not going to buy the car, and on to the right, which is 1, they're going to buy the car. And whatever you see the dots here, these are the actual data. That means you will see the red dots, and in red zone, that means they are correct. You see some green dots in red zone, there's something wrong, because I have predicted that he's not going to buy the car, but he has actually bought the car. Okay. Similarly, on the right hand side, if you see, there are some green dots. There are most of them, you have green dots in green. That means your prediction and actual is 1. But there are some red dots in the green. That means these are the red dots, which are the guys who have not actually bought the car, but the prediction that is he's going to has bought the car. Okay. Have you understood till here what I said? What have you understood this prediction boundary? Very, very important. Anybody who has understood, say yes. Anybody not understand, say repeat or no. Have you guys understood, right? Very, very important, right? So this is the way you understand, so that this is the way I will see visually through a graph as to whether how many green dots are in red, how many red dots are in green, how many red dots are in red, how many green dots are in green, right? So this is how you will find out, or you will make out whether this model is really working or not with the data that you have provided. Now, in the case of classification, just as you had the R2 score to measure the efficiency of the regression model, in the case of classification, the way to measure the efficiency is called confusion matrix. Now, you please don't ask me how the word confusion matrix come, because I am also very confused with that word. But we all have to live with that, okay? Unless Sunny, you have some convincing answer why how the word confusion matrix came. But anyway, the word is confusion matrix, which is basically to use the efficiency of the model. Now, I am going to show you a particular. Please look at this particular slide. Very, very important. What you have is a predicted value, which will either have 0 and 1. Means 0 is not going to buy the car, 1 is going to buy the car. This is the actual value, test data value, where the 0 means he's not going to buy the car, 1 is going to buy the car. Now you will see there are 35 samples out of 100. If you remember, there were 100. There were 35 samples where the predicted and actual value is all zeros. Predicted and actual value is 0. That means my actual value is not going to buy the car, and it is predicted is not going to buy the car. Okay. This is absolutely correct. This is called, there are 35. Now look at this 50. We have actual 50 samples where he is going to buy the car, and the model also predicted that he is going to buy the car. Okay, so these are correct cases because the prediction and the actual values are the same. But come to this. you have 5 cases where the actual value says that he has not bought the car, but the predicted value says that he has bought the car. Okay? And there are 10 cases where the prediction says that he has not bought the car, but actually he has bought the car. So these are the wrong ones, right? These are the wrong ones. Okay? Now, if you want to measure the efficiency of this particular model, you measure the efficiency by a term called accuracy rate and error rate. So when I say accuracy rate is 35 plus 50 divided by total, which is 100. So accuracy is 85%. So my model, my confusion matrix model in a classification model, the way to measure the efficiency of that model is using the term called confusion matrix, and within that you have something called the accuracy rate. So higher the accuracy rate, more efficient is the model. So if the accuracy is close to 100%, it is the best model. Or if the accuracy is maximum, obviously error rate will also come down. Now I am going to explain this you in another way, very nice way of doing this. Now assuming that zero means that a person is not suffering from cancer, and 1 means he is suffering from cancer. So this 35 and 50 we are clear. If he does not have cancer, predicted he does not have cancer, actually also he does not have cancer. 50 is also okay, it is predicted he has cancer, actually also he has cancer. Now look at this 5. The model is predicting that he has cancer, but actually he does not have cancer. The model is saying that model is predicting that he has cancer, but actually he does not have cancer. Still it is okay. He actually does not have cancer, but he's predicting he has a cancer. Okay, it's still not that fatal, but it is a serious matter. Okay, but the most issue is this 10. You have predicted that he does not have cancer, but actually he has cancer. This is the most fatal. That's why it is put red here, right? You cannot have this case. I mean, if you are doing a prediction that he is not having cancer, but actually is having cancer, then it's a big problem, right? Okay, so in machine learning terms, these are called the false positive or the type 1 error, and this is false negative or the type 2 error. Okay, so the type 2 error is the most serious. The type 1 error is serious, but it is still manageable. But this is the one which you should manage. So you have to reduce this as low as possible. If this is high, your model is not good. Okay, so you have to really take care of the type 1 and the type 2 error, which is causing the reduction in the accuracy rate. Any questions on have you understood the concept of confusion matrix? Very important. If you want, I'll repeat it. Please answer yes or no. Have you guys understood the concept of confusion matrix? Okay, Ansari, you are good. Okay, Shruti is good. Lakshmi is also good. Anybody else who needs some clarification on confusion matrix? Great. It's nice that all of you have understood in the first instance, because myself, okay, who was that? No, sir. I myself took 10, somebody has to explain me 10 times to understand this. So you guys are smarter than me. Who was the guy who said that he didn't understand? Who didn't understand? I saw somebody saying no. Okay. Let me just quickly repeat for the benefit of everybody. Okay. So as I said, there is something called confusion matrix. Okay. So you have here the predicted and the actual value. Okay. So where the predicted and actual value is same, here 0, 0 and 1, we are good, right? Where we are talking about an accuracy of 85% here, because 35 plus 50. But for a model to be most efficient, your accuracy rate should be close to 100%. So you have to eliminate this 15. Now what are these 5 and 10? These are the cases where the prediction and the actuals are not matching. So I took out the example of a cancer patient where your prediction value that he has got cancer, but he does not have cancer, but actually does not have a cancer, which is a less sort of a fatal, which is called type 1 error, which is called false positive. But the most important is the false negative, where the actual value is that he has cancer, but the prediction he does not have cancer. Okay, so this is very serious. So you have to reduce the type 1 and type 2 errors in order to improve the accuracy rate. So this is how you measure the efficiency of a confusion matrix. Okay. Now if I come back to this, there was one step I skipped here. Here I'm doing from sklearn matrix, import confusion matrix, and then I'm using CM confusion matrix. I'm using parameters of ytest and ypred, the predicted test data and the actual test data. So if I run this, and if I enter CM here, you see the same thing which I showed you here. So what is the accuracy rate? What is the accuracy rate in this case? Anybody, what is the accuracy rate? %89%, correct. Okay, 65 plus 24 divided by 100. So this is the way you will calculate. So you can also print this, right? You can print this and you can print the percentage. That's not an issue. But this is the way what I showed you in that slide is. This is how you represent it, right? So this is the one which is the true positive. So okay, this is the correct one, and these are the false positive and false negative, right? So the type 1 and the type 2 errors. Okay, so this is the way you calculate the efficiency of a classification model. Okay, so we have covered logistic regression. Okay, now we will go to next one is decision tree, and can I request somebody to give presenter rights to Sunny, please? 1 minute, whether I can do it. Let's check. Let me check if I can do that. Sunny, okay, 1 minute. Sunny, you have the presenter rights?
Yes.
I made it presenter.
Yes, sir. I will see it.
Thanks, thanks.
Okay, so is my screen visible to you all?
Yeah, we can see.
Okay, thank you. So once again, very good morning to all of you, and thank you all for joining today. So let us start with a few basic discussions on it, because right now we discuss about confusion matrix, and the objective of the confusion matrix, or why is it called confusion matrix, is very simple, because it actually helps you to understand if the model that you have developed is confused between the two classes or not. Because ultimately what you want is a model which is reliable and which is able to understand that yes, okay, why is it able to say that if the person is going to buy the car or it is not going to buy the car. Okay, so my voice does not seem to be clear. Let me try again. Okay. So the objective of the model was to predict customer is not going to buy the car, and it is expected that
Your voice is not clear. Your voice is not clear, Sunny.
there is a yeah, is it better?
Yeah, now it's better. Yeah.
Oh, please hold on.
I think it can be still clearer if possible.
Hello? Hello, is the
Yes,
voice
Sunny,
better?
yeah, it is better. Yeah.
Okay. So
Everybody
what we
can
are
hear
discussing?
Sunny? Yeah. Maybe somebody from the students can say, are you guys able to hear Sunny? Sunny sir? Yeah, okay, Sunny. Yeah, go ahead.
So,
Yeah, Sunny, your voice. Yeah, go ahead.
okay.
Sunny, do you
So,
want to use
thank
the
you.
audio? Sunny, you want to use the audio of your own audio instead of the audio of the software, because you remove the plug and put it back. You can select a new hardware where you
Okay,
can
let me
use your
try.
own speaker. And and you select a new hardware option.
Hopefully my would be a little better now. Uh, Please confirm me as I speak. So we were discussing right now what is the objective of a confusion matrix that we have understood, what is the use of the confusion matrix. But what we are discussing now is why a confusion matrix is known as a confusion matrix. And that's because we want to validate if the model that is learned based on the data that we have given, does the model have any confusion in the model's mind, or if it is clear to the model why it is saying the person is going to buy the car or why it is saying that the person is not going to buy the car. So the confusion matrix is to validate that the model do not have any confusion. It is very clearly able to learn and very clearly able to say or differentiate or derive relationship that says that based on these relationship the person is going to. That is why we call confusion matrix as a confusion matrix, because it helps us validate if the model is confused or if the model is not confused. So right now Arunjit sir explained us about the accuracy rate or the other parameters related to false positive, false negative, true positive and true negative. So these are some of the parameters with which you can validate that yes, model is not confused, model knows very well, model has derived those relationships that help it understand that why the model is suggesting buying car or not buying the car. So as an end user, the data scientist, when you wish to deploy this model in real time, your objective is to validate that the model is not confused and you can take decisions completely reliable output of based on the completely reliable output of the model. And that is why we call this confusion matrix. From there, let us move on to the second part of our today's presentation, that is discussing about decision tree. So what we have learned till now is we started with regression where we saw how do we identify that the relationship between variables is polynomial, and then how do we use various degrees of polynomial to best fit the model to the data. Okay, so I think when Arunjit sir was explaining that, it was a classical example that when you develop a model for the first time, you give the data to the model runs, the output are generated. So none of the model or never a model is developed in first iteration. The models are always and always and always developed with multiple number of iterations that need to be done. Uh, if you all remember, Ranjit sir started with first degree, then went to second, then third, and then fourth. And in the fourth iteration, when he tried fourth degree of polynomial, then we were able to get the best fit. So this is how models are developed. Multiple iterations happen in the background, and based on those iterations, the final model is developed. So in the morning, we started doing this manually. We manually did certain number of iterations in order to come up with the best fit. Now that iteration can also be automated, and that becomes one of the key factors of the model that we are going to learn now, that is decision tree. So what is a decision tree, why it is called a decision tree, and how does it help you? Let us try and understand that. So for that, imagine that you are playing tennis every Sunday. Okay, every Sunday you are playing tennis, and then you also invited one of your friend to play your tennis every time. Every time you go out to play the tennis, you invite your friend to join you. But friend sometimes comes to join you and sometimes does not come to join you. Okay? You invite your friend every time. But every time your friend do not join you, he or she only joins you sometime and sometime doesn't. Now you have this thought in mind. Why does a friend joins me sometimes and why he or she doesn't join me sometimes? And you want to identify that. So with the help of machine learning, today what we are trying to do is we are trying to see what are the critical environmental factors that leads to the decision of your friend. Okay, because when your friend comes to play with you sometimes and when it doesn't come to play with you sometimes, there is something going behind in your friend's mind that we are trying to learn through decision tree. So in this case, some of the factors based on which the decision of your friend is dependent, we are understanding that it is the weather. Okay, what type of weather is there? It is the temperature. What is the temperature outside? Is it warm? Is it hot? Or is it cool? Uh, and then what is the humidity and also what is the wind? So basically, these are some of the factors that affect one's physical fitness or the way we play our tennis. So that's why we thought your friend has some logic in her mind, and based on that logic, she doesn't come out to play with you every time. And that is what we are trying to understand with the help of machine learning model. And in this case, it's known as a decision tree. So let's go forward and see how does a decision tree work. To start with, the first step in a decision tree is known as a root node. Now, all of you have understood that why a tree is called a tree. So, tree is called a tree because tree has root, it has a trunk, and then it has various branches. So, what you can right now see on your screen is an inverted tree. Now, the tree, when you look outside your window, you see that the trunk is below, the roots are below, then we have a trunk. From trunk, we have several different branches. Now just try to invert a natural tree which we see on roads, which we see on ground. Does the structure that we right now see on the screen resemble to what we see on the roads? Are you able to resemble with the same structure? Yes, there is a trunk, then there are several different branches. Okay, that is why this type of machine learning model is known as decision tree model, because as the tree grows, it develops more and more and more branches. Okay, similarly, as the learning of this machine learning model grows, as it learns more and more logic based on the data that is given, it actually develops more and more branches which helps you to take decision, right? So right now the node from which you start or from which the machine learning model starts learning is known as a root node. Okay, that is known as a root node. From the root node or from the trunk of a tree, what comes out is known as a branch. Okay, so here what you see is where the outlook is either sunny, is it overcast, or if it is raining. So those are known as splitting of the root node, and once the node are split, you develop different branches, right? I'm sure by now this much is clear to everyone, where we started saying that yes, the structure of a decision tree is somewhat like an inverted natural tree that has trunk on the top and branches and leaves on the bottom. So we start with a root node. Now, how does a decision tree identify that what is a root node? That we will come a little later. But right now, please understand that, or please remember that the first module or the first node is known as a root node. The root node is further divided or it is further split into various different branches. Okay. Now, on the screen, you can also see there is something known as decision node. Are you all able to see this decision node? Hmm? I believe there is some lag between what I'm saying and what I'm doing on screen and probably what is reaching to you. But this is a decision node. So why is it a decision? Why is this splitting known as a decision node? Or why is this branch known as a decision node? That's because after this node, here we are writing humidity. After this node, you come to a final conclusion. Okay, after this node, after the decision node, you come to a final conclusion, and that is why these nodes are known as decision node. Right now, what you can look on your screen is only one split. Okay, it's only one split. So it started with root. It developed one branch from this first branch, and then finally it came to leaf node where you got the decision whether your friend is going to come to play tennis with you or she's not going to come and play tennis with you. So that's why here we only have one or we only have two splits, but there can be hundreds of split. Okay, so decision tree model right now what you're seeing on the screen is a very simple model. But in real life, when you have the data available with you, this decision tree model can split more than 100 branches. Okay, so usually we try to develop so as many branches the decision tree has, the better it will be able to learn, but then not more on the number of branches, otherwise it will overlearn. So I'm sure this must be very clear to you now that what are we doing? We are providing the data to the decision tree model, and the decision tree model based on the data that is available to it, it is just trying to break. It is just trying to break it in different smaller sections in order to arrive at a decision. Okay, is this all clear to you? Can you all please respond on the chat box? Is this clear to you, or is there any confusion? Okay, so so the objective or the basic understanding of the decision tree is clear. Now, can you all also see if I take you back to what are the several factors that we are considering? One factor is weather, the second factor is temperature, third factor is wind. Okay, right now let's come back here and see at what are the different factors that we see here. Hmm? So one factor that we see here is outlook. What is this outlook? Is actually the weather. Weather means either it is sunny, it is overcast, or it is rainy. Okay, so what does it mean that your friends when it come out to play with you, before she gives you a decision that she is going to come out or she is not going to come to play with you, she first look at how is the weather outside. If the weather is sunny, okay, then your friend will further think about humidity. But and also if the weather outside is raining, your friend will think about windy if the environment is windy or not. But if it is overcast, the it means that the weather is very nice. Then your friend will say, "Yes, I'm going to come and play with you. I don't need to do a second thought." So can you see that your friend is first of all trying to see that if it's not going to if your friend has more chances to win when she comes out to play with you, she's going to come out to play with you. Otherwise, she's going to think if the weather is sunny, then it's going to sweat her a lot. If it's going to raining, then it's not going to be a good time to play, so she may not come out. So the first split happens on the weather, on the outlook, if it is sunny, if it is raining, or if it is overcast. Is this clear to you all? Can you please all confirm on the chat box? Is this clear to you all? Okay, very good. Now, an important question, like why is the first root node or the first variable which is selected as first as the weather and not humidity or not windy? So if you guys all remember, yesterday we discussed about a concept known as entropy. Do you all remember entropy? Do you all remember entropy? We discussed about entropy yesterday. Do you remember? Okay. Okay. noticed someone has started replying that you remember about entropy. Entropy is basically the amount of randomness in the system. Okay, so more the randomness, more the entropy in the system. Okay, so what the decision tree first try, I told you yesterday that these models they try to minimize the entropy in the system. Okay, they basically try to minimize the entropy in the information. For the decision tree identify that the first variable is weather, whether it's sunny or overcast or rain. If you declare it as sunny, if you declare it as overcast, if you declare it as rain, then the amount of entropy in the system is reduced. Okay, there is a mathematical formula to calculate this, but that probably we are not covering here. But then there is mathematical formula that help the decision tree understand whether looking at humidity or whether looking at windy or whether looking at outlook, which is the first variable that will help minimize entropy of the system. From there, we identify that okay, now the weather is sunny. Okay, so if you see before outlook, what was the probability of sunny, overcast, or rain? So the probability of weather being sunny was 1 by 3 because there are 3 different possibilities that can happen, and all 3 different possibilities that we are seeing right now, sunny, overcast, and rain, these possibilities are are mutually exclusive, so they cannot occur at the same time. Okay, so earlier the probability of all these events was 1 by 3, but now as you select that the weather is sunny, automatically the probability is come down to 1, where it is says that yes, we have selected that it is sunny, the weather is sunny. From here we come on to looking at the second parameter, which is a humidity. So in the humidity, once again the model tries to further develop branches, and when it tries to develop branches, it looks at the data. When it looks at the data, it is trying to once again minimize the entropy in the system, and the model identifies that if the humidity value is less than equal to 75 or it is greater than 75, then the entropy automatically reduces in the system, and we can come down to a conclusion. So what it says that the first line here says that your friend looks at if the weather is sunny, then she will look at humidity, and if the humidity is less than 75 in the environment, your friend will come and play with you. Okay, so that is why the answer is yes. Okay, if the weather is sunny, if the humidity is less than 75, I'm going to come and play with you. On the other hand, if the weather is sunny and if the humidity is more than 75, your friend will say, no, I'm not going to come and play with you. So that is how the decision tree helps you to derive conclusions based on the data that is available, right? So if this was all clear to you, the first step is clear to you, could you please all respond on the chat box? Okay, so Shehzadi Shruti Mubin says that yes, it's clear to you. Now let's see. Neha also believes that Neha, Lakshmi, Ruvail, it is clear to all of you. Now let's come to the second part. One is sunny. The second, that the weather is clear, the weather is perfect to play. Then your friend doesn't give a second thought, simply pick up the racket, come out to play with you, and then both of you enjoy playing. Right? So when the weather is here overcast, it means it is clear, then your friend doesn't give a second thought. Now let's come to see if the weather is raining. Okay, so if it is raining, then your friend will see that if it is windy or it's not windy. See, when it is raining, obviously there is good humidity outside, so your friend is not going to look at humidity because the environment itself has a lot of humidity. So, but if it is raining, then your friend is going to look at if the environment is windy or not. If it is windy outside, if she opens the window and see that yes, there's a lot of wind blowing outside, then she is not going to come and play with you. And when it is not windy, then now you know that yes, my friend is going to come and play with me. Okay. So earlier you had confusion that sometimes you call your friend and your friend comes out to play with you, and sometimes when you call your friend refuses to come and play with you. But you never understood why is your friend doing like that? What is the reason? And then now you have learned machine learning, you have learned statistics, you are a data person now, so you started collecting data on a piece of paper. And after collecting data, um, then you run a decision tree model, and your decision tree model is now able to understand that yes, if the weather is sunny and if the humidity is less than 75, my friend is going to come and play with me. But if the weather is sunny, if it is humidity, if the humidity value is more than 75, then my friend is not going to come and play with me. So now you can predict in advance. You don't have to go to your friend and ask, are you willing to come and play with me? You will look outside whether it is sunny, overcast, or raining. If it is, what is the humidity level? What is the wind speed? Based on that, you will decide that your friend is going to come and play with you or not. And that is how you develop a predictive model. Okay, is this clear to you all? Yes. So this is clear to you all, right? So I'm asking you. So let me ask you a quick question here, wherein you answer me. Okay, you have a friend, and I'm giving you an environment on the chat box. You all tell me whether your friend will come and play with you or not. Okay. Okay. It's raining and it is windy. Your friend is going to come and play with you or not? No, no. So your friend is not going to come and play with you. Okay. Now it is sunny. Okay. I've given you the second question. Then you all respond. Yes. So Shahzadi, Sanjana, Mubin, Vijay Lakshmi, Tejasvi, Anjana, Nirmala, all of you are going to get your friends to play with you. Now let me ask you a second question. So the third question, can you all respond? Can you all respond for the third question? It is sunny plus it is windy. Can you all respond? Sunny plus windy. Is your friend going to come and play with you or not? Okay, so many of you are saying yes. Let me repeat my question. Sunny plus windy. So the answer is no weather like that. Yes. So there is no condition like that. So if you have a data wherein you say that it is sunny and it is windy, then this decision tree model will not come and help you with your output. It's not going to come and help you because it doesn't know. It has not seen that condition. That's why it is not going to come and help you with that. Okay, so that is the reason that machine learning model needs all of the data for which it was trained, and for that only yesterday we learned several feature engineering practice. Okay, because if you don't, out of the three data which is needed here, which is the weather, how is the humidity, and how is the wind condition outside, if you have none of if you have, even if you have one of them missing, then probably you cannot arrive at a decision. Let me give you a second output. So this is my fourth question. Okay, so fourth question is out, waiting for your response. So Shehzadi says no, 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 no. Humidity is high. Okay, no. Now can you all please look on your screen and then see how is decision tree making a decision? Can you all please look at the screen and see? The question was overcast plus humidity 75. Will your friend come and play with you or not? Or humidity greater than 75? So Shruti says yes. Shruti, are you going to treat your friend with McDonald's? That's why she's going to come and play with you? Why? Okay, now everybody says yes, but why? Okay, Shehzadi also believes that her friend is going to come and play with her now. So any incentive that you have given to your friend Shehzadi? Why your friend is going to come and play with you now? Because less than equal to it. Nope, nope, nope. You're not looking at your screens. Everyone, can you please look at your screens? What is the first variable? What is the first variable? Can you please all respond? What is the first variable? Wait. First variable, what I'm writing down is overcast and humidity. Okay? Overcast and humidity. What is the first variable? The first variable is weather and the weather is overcast. Okay? So can you look on your screen and then say if the weather is overcast, then what do your friend do? Play. Yes, she comes to play. What is the role of humidity when the weather is overcast? What is the role of humidity when the weather is overcast? No role, Shehzadi. Then why you said earlier that the humidity is less than 75? So whatever you have learned, there is a lot of confusion in my, and your confusion matrix is not giving the right answer. Okay. So let us very quickly repeat. The first variable is what is known as a weather here. So weather is sunny, weather is overcast, or weather is rain. If the weather is overcast, whatever be the humidity, whatever wind condition outside, your friend is going to come and play with you. That's very clear. The data very clearly states this, that if the weather is overcast, your friend is going to come out and play with you. It is clear. Okay? You can see that this is the root node, there is a splitting, and then there is an output. So it's extremely clear. Now there is a split here if the weather is sunny. If the humidity is less than 75, your friend is going to come and play. If the weather is sunny, if the humidity is more than 75, your friend is not going to come and play. And if it is rainy and if it is windy, your friend is not going to come and play. And if it is raining and if it is not windy, your friend is going to come and play with you. Okay, let's do the quick revision now. Next question to you is, say it is raining plus humidity is more than 75, whether your friend is going to come and play with you or not. Quick. No role of humidity. No. How do you say no? Why do you say no? Why do you say yes? And decide. That's the right answer. Okay, that is the right answer. You can't decide because if it is raining and there is humidity, so we can't see any branch here that talks about raining and humidity, so you can't decide. So if you have a data that says that it is raining and it is humidity, your machine learning model will not work. It will be confused. It will not give you any output. Okay, is this clear to you all? Now let me repeat another question. I hope this time all of you will give correct answer. So please be careful. Please be careful. Please be careful. So some are saying yes, some are saying no, some are saying can't decide. Shruti saying can't decide. Anjana saying can't decide. Shehzadi says no, can't decide. Why you can't decide? Why you cannot decide? Why you cannot decide? Why you cannot decide? Overcast means she will say yes, correct. But still somebody is saying can't decide. But sir, it's Sunny. Yeah, my name is Sunny, I agree. But then why Sunny and Overcast, she's going to play or she's not going to play? Okay, now I want you to carefully listen, everybody. We started saying that we have mutually exclusive events. It means Sunny and Overcast, they both are mutually exclusive events and both of them cannot occur at the same time. So if you call out to your machine learning model that it is Overcast and it is Sunny both at the same time, your machine learning model will not give any output, right? That is why we studied probability on the day one, because all the events have to be mutually exclusive. If the weather is sunny and overcast at the same time, your model will not be able to predict any output. Is this clear to you all? Sunny and overcast at the same time, it means that these events are not mutually exclusive. So such a condition is not possible. Did you all get the point? Now the condition is sunny plus raining. It is sunny plus it is raining. Not possible. Very good. Why not possible? Swati, Shreya, Nirmala. Why not possible? No mutual weather, no output. No mutually exclusive weather. Yes, very good, Shreya. It is mutually exclusive events. Right? So I'm sure this must be very clear to you that first of all, the event from where it starts, these events or these categories in the data have to be mutually exclusive. If these categories are not mutually exclusive, any machine learning model, be it how complex or how simple, will not work. And that's why we learned probability first. So going forward, all of you please very well feed this in your mind that the categories which are there in the data have to be mutually exclusive, that they both cannot occur at the same time. Otherwise, no machine learning model will not work. Now, just imagine that you have a mutually exclusive event. You don't have a mutually exclusive event, and then the output would be, will you buy the car or will you not buy the car? So, can both of them occur at the same time? Can a machine learning model come and say, or can you physically in the car showroom do both the things? You buy the car and you don't buy the car at the same time. Is that possible? No. No. So that's not possible, and that is why categories in the data have to be mutually exclusive. Okay, now I'm sure this must be clear to you. So let's proceed. We started with root node, from where the machine learning model starts dividing. Splitting the branch node is known as a root node. Then we have split. Then we have various different branches. We have a decision node. After the decision node, we have the leaf, and leaf is the end of the decision tree. Okay, so this is the overall structure of a decision tree. From here, let's move on to the second part. So now decision tree. So decision tree basically uses an algorithm which is known as ID3, and this algorithm uses information gained to decide the splitting criteria. So ID3 is a type of algorithm. There are various different algorithms that are used for decision tree. One of them is ID3. So in this algorithm, what happens is, if you look on your screen, there is a graph. Okay, there is a graph. Now, what does this graph help you understand? If you see, the probability ranges from 0 to 1. And yesterday we studied that if the probability of the event is 50-50, 50% yes, 50% no, or 50% buying car, 50% not buying car, 50% having a disease, 50% not having a disease, and then 50% sunny, 50% the overcast, then that is a place where there is highest entropy in the system. So a decision tree model, what it does to try is, when it does splitting, it tries either to go from the center, either on the right side where the entropy reduces, or it goes on the left side where the entropy reduces. Okay, that is the overall, that is how an ID3 algorithm works. ID3 algorithm starts from the middle. It starts from the middle, and then it tries to go on the left side, or it tries to go on the right side where it is able to minimize the entropy in the system. From here, let's go to understanding that if the sample is completely homogeneous, the entropy is zero, and if the sample is evenly distributed across classes, then it is an entropy of 1. So somebody replied today. So my appreciations to you, because somebody replied that entropy is 0 or entropy is 1. So we saw that, and we from there we move on to the next part, wherein we understand the next section. So Shilpa replied that entropy value with 0 and 1, and someone else also replied. So good job, good one to both of you. Okay. So the next step is to make the split that minimizes entropy. From here, let's take the next example. Let's go forward. So here we have taken an example of the root node, the same problem, where we start splitting with humidity. We see here that the root node is humidity, what is the entropy, and what are the different leaf nodes. So suppose if the humidity is less than 75, can you all see on your screen that the humidity is less than 75, then the entropy of the next system becomes 0, and there are 4 samples in the data that says that yes, your friend is going to come and play with you. At the same time, if the entropy in the system is more than 75, then then there is probability that your friend will say that okay, I'm not going to play with you. So that is